All right, let's see if we can make clear having questions about probability and normal distribution. So we know normal distribution, we have the bell curve, and right down the middle we have the mean, which is often given the Greek symbol mu, and then we have the standard deviation, so this would be mu plus sigma, and sigma is standard deviation. And then we have real world data. So it sounds like what you can already do, real and then z-score. So the real, we have a formula that's x equals mu plus z sigma. So if you have mu and sigma and a z-score, you can find the real world data. And if you need the z-score, then that's z equals x minus mu divided by sigma. So there's formulas to go backwards and forwards between real and z-score. Now, if with the z-score, you can look up on the z-score table. And the z-score table will give you the probability to the left. Oops, that's not an L. I don't know if I have a z-score table. I think I do. Let me just look real quick. There we go. All right. So for example, if we have a z equals negative 1.2, we look up on the z-score and we get negative 1.20, 0.1151. So the table value is 0.1151. So z-score negative 1.2 would be about here. And the 0.1151 is the probability that a value will be to the left of there. Or we could say 11.51% of the values are to the left of there. Or we could say 11.51% of the area of this curve is in that red region. So going from z-score to table is just a matter of looking it up in the table. So then there's basically three concepts. If we want the probability to the left of a z-score, then there's also probability of right of a z-score, or there's the probability between two z-scores. And now it might not be between z-scores, it might be between two real values, but we already know how to go from real values to the z-scores. And tables only accept z-scores. Okay, so to the left of the z-score, this is exactly the table value. That's it. To the right of a z-score, you have to do 1 minus the table value. So if we wanted to the right of negative 1.2, 1 minus 11.51. So 11.5%, 1 minus that is 88.49%, whatever that is. That's the other area. The total area is 100%. So you just do 1 minus the table value and you get the probability or the percentages to the right of that certain z-score. If you have two z-scores, you'll get two table values. Then the probability is the larger table value minus the smaller table value. So if you're given this, you want to find this region right here, you have to find the z-score for each of these edges. Look up the table values. The table for z-score 2 will be a larger number. And we know this because the larger the z-score we get, the bigger these numbers get. And then the z1 will have a smaller table value. So you take the larger table value, subtract the smaller table value, and you get the percentage in between, or the probability it's in between. Now, slightly harder problem is if you're given like a percentile. Let's say we're in the 20th percentile. The interpretation of the 20th percentile on a bell curve is that you are at a spot where there's 20% to the left. A percentile is always to the left. So what we are basically given is the table is 0.2000. That would be the 20th percentile. So our job is to go into the z-score table and look around until we find 0.2. And it won't be perfect because there's no exact 0.2, but there is a 0.2005. That's the closest, so we go with its z-score. That's negative 0.84. Again, negative 0.84 is the closest one that has the 0.2 in the table. Negative 0.84. Let's put a negative 0 point. And then from there you can go back to the real world value with formulas. So hopefully this makes more sense on how to take a z-score to the table, and then depending on what question they ask, how to use the table value or values.